Welcome back, students. In our last video, we have discussed about the introduction to linked list. We have seen that linked list is a data structure where data is stored in form of the nodes. And node contains two parts. One is the data part, another one is the address to the next node. So in this video, we'll talk about how the linked list is implemented in any programming language. Specifically, we shall talk about the Java programming language, right? So we in our previous lectures we have discussed already that what are the advantages of arrays and disadvantages of the arrays, and what are the advantages and disadvantages of the linked list. Linked list is a good data structure if you are frequently performing insertion and deletion, because insertion and deletion are very efficient processes methods in linked list. So in this video, we'll talk about the implementation of the implementation aspect of the linked list. So these are the list of methods that we shall be implementing in our code, right? In this code. So what do I mean is, let's say, let me move this to step a little bit here. So more specifically, we will be seeing how to add a node at the first index, how to add a node at the last index, how to add the add, and many methods are there that we shall discuss one by one, and we shall be looking for the code of all these methods in our code in our today's video, right? So let me create a new Java project very quickly so that we can implement it. So let me create a new package in my folder that I have already created for you for this course. Let's say I'm going to say a linked list package. And in this package, I can create a new class, say linked list. Remember, linked list is already a class, predefined class in Java, which is java.util package, which is in the collections framework. So you may think that how can we have the same name for our own class? Since we are using a different package, there is no problem. You can have the same name. Otherwise, in the same package, you cannot have multiple classes with the same name. Since the package is different, we can use the same name, linked list, right? And at the same time, I'm going to create another class, which is the linked list tester class, so that I can have my main method here that I can use here, right? Linked list test class. So we will be having this main method here that we will be using to test our class, right? Okay, first of all, what do we need in the linked list? In a linked list class, what I need to have is, I need to have the nodes. I mean, in a linked list, we will be creating nodes. So a node is collection of two things. One is the data part, another one is the address to the next node. In order to do that in Java, to group multiple data types into one, we can create class. So I'm going to create an inner class for this linked list class. So if you are not familiar with the inner class is a class within in another class, like we have the inner for loop, inner if condition. Similarly, we can define a class within another class, and that class is called a inner class, right? And the outer class has the access to all the methods, all the variables of the inner class. So it doesn't matter if you define the inner class as a private class or a public class. The only thing is, if you define the inner class as a public class, somebody else can create the object of that class. But if you want to make that class private, this is the only place where you define the private classes, which is the private inner class, right? So in our project, I'm going to define a private inner class, right? Private class, say node, right? And what type of data this node will handle, as we have seen in our array list implementation, we will be using generic data types. So I'm going to define a generic type like we use any type in our previous video. So let me, just to make it short, I'm going to write T over here, that we will be using T as a generic type, and it can handle any type of data, whether it is a string, integer, double, float, whatever the data is, or even a complete object is given, it will handle to store that object as a linked list node. Okay, what this node will contain, obviously, first of all, this node will contain a private variable, right? Private which is the data part. What type of data we are going to store? T type of data, because this is my user defined data type, right? And the other thing is we will store the address to the next node. That is actually how we are going to link the list, the different nodes of the list. Since we want to store the address of the next node, this variable should be of the type node. So I'm going to define node, right, of type, private node, say next, right? So after writing this, this node class has two instance variables. One is the T type of data, another one is node type of next. Okay, let me define the constructor for this class, and let me define, because this class is private, I can define the constructor private as well. So private node, and what I'm supposed to do in this constructor is simply to set the data to null and next to null also, right? So there is no confusion, no problem in while I'm going to create it. Okay, this is a class, member class of my linked list class, right? And like we have the instance variables, we have the inner classes. Now, what else I have? I need to have in this my linked list class. One is node itself. Another one is how many nodes do we have in the linked list? We know that we can have the dynamic, the linked list is a dynamic structure, right? So we do not need to fix the size, but at least I need to know how many nodes are available in the list. For that, I'm going to define an instance variable of type integer with the name size, so that I can maintain that how many size of the list with the number of nodes is equal to the size. The third thing that I need to have over here is, as an instance variable, is one node type of a head node, right? So that I need to define. So I'm going to define a private node, right, of course, of type T with the name head. So why do I need this one is to, as I mentioned in our previous video in the introduction, that node, the linked list has a starting point, which is called head node, right? So in my main program, in main, if I try to create the object of this linked list class, linked list, for example, of any type, let's say list is equal to new of linked list, right? If I simply do this, I'm going to call the constructor of this linked list class. What will happen if I do so? An object of the linked list class will be created like this one. What does this linked list class object will have? It will have, so if you go and see what does this contain, it contains two things, right? Third is the class that we have not created the object for. Only two things. One is the size variable, another one is the node type variable, which is head. So after writing this line of code, what will happen is, let me just draw it here so that we can see here. So what will happen is one size variable will be created and one more variable will be created with the name head, right? This head, let's see, let me just label it. So this is the variable size. Let me just change the color, writing color. So this is size variable, which will create, since we are going to create this, right? So nothing, right now, nothing is there. So another one is head, right? Head, whose type is node, right? Whose data type is node. Node is an inner class of this class, right? Okay. Now, once I have this, let me just call, because we do not have any constructor in our linked list class, so the default constructor was called. Let me define my own default constructor. Public linked list, which is the default constructor. And what am I supposed to do in this list in constructor is I'm going to set size is equal to 0 and head is equal to null, because right now the list does not contain anything. So I'm going to say this is 0. So what I'm saying is size is 0 and the head is null, right? Size is 0 and the head contain null. It doesn't contain anything at this point. And this whole is basically the object of my linked list class with the name list, right? This is the list, which is the object of linked list class, right? So after calling this, creating the object of this class in the void main, this would be the position of linked list class, the object of the linked list class, right? So, okay, now let's see. What am I supposed to do here? First of all, I have to add some values, some nodes to this one, right? So what I'm going to do here is I'm going to write a method to add some nodes into my linked list. So there are many methods that we have to write, right? For example, add first, add last, add a given index, and so on. So let me write this add first method, public void add first. Add first method will accept a data that we want to add into the list, right? Since this add first method will add the node in the beginning of the list. Remember this add first method always add the node in the beginning of the list. So what will happen when I'm going to call this method add first? First of all, what I need to do, I need to create a new node. So first of all, I'm going to create a new node, right? Say suppose new node is equal to new of node, right? So what will happen when I will write this line of code, and when this method will be called, what will happen is, so let's say a new node will be created like this one. Let's say a new node is created like this one. Say a new node is created, which has two parts, right? We already know the node contains two parts, right? Which is, if you observe here, we have one data part, another one is the node type of address to the next node, right? So if I label it, this is my, let me just change the color so that we can differentiate it. This is my data part. This refers to the data part, right? And this is the next, right? And this is the new node that we have just created after writing. Whenever this add first method is called, this is going to call this line of code, which will create a new node, right? Okay, now let's say this node is created on some memory address, let's say for example 250, right? So this is created on the memory address 250. What am I supposed to do in this node? First of all, of course, whatever the data I have received, I will be storing this data into this data part of this node. So that I am saying, hey, new node dot data is equal to the data that we have received as an argument. Store this data into the data part of this new node, which is this part, right? This one. Okay, once I am done this, what next I have to do? Now I have to place this new node as at the head node, right? But I am not sure right now the linked list is empty or not. If the linked list is not empty, then head is pointing to some other node already. So in that case, what I'm going to do, I'm saying, hey, new node dot next part, whatever head is pointing to, add it here. So head is pointing, whatever head is pointing to will be over here. Right now head has null. So after writing this line of code, what will happen? This next would be having null here. Let's say this next would have null. Whatever is the head part will be copied here, which is null, right? Because head does not contain anything. Now, next, once I am done this one, now what I have to do? I have to place the address of this new node to the head node so that head can point to this one. So that's what I'm saying. Head is equal to now new node, right? What does this mean? This means the new node which has the address, okay, which has this address 250. So head will no more have this null part now. This will contain 250 here. This will have 250, right? And that means this is pointing to this node, right? And whatever data we have received will be placed. Let's say suppose we have received data 50. So the 50 is over here, right? Okay. Now, once I have done so, that means I actually have established the link. And now I can say once I have added a new node, I have to increment the size. So I'm going to say size plus plus, so that I have added a new node and size is added over there, right? Size is incremented. So let's say if I now write this method here, list dot add first, for example, 50, right? So 50 will be added as the first node. That how can I check now? Let me write a toString method so that I can print out this list and I can see whether this node is added to the linked list or not. So in order to write the toString method, let me just say public string to string, and this toString method is going to return the string representation of the whole list. So what am I going to do in this toString method? Of course, I'm going to create a string type of variable str, which contains the opening bracket only, right? So that I can print it nicely like this way, right? Like this way. Okay, and then first of all, I have this opening bracket. Now what I have to do, I have to go and check each and every node, right? For example, if there are 100 nodes, so I have to get data from every node and add it into the str variable. In order to scan all those 100 nodes, I have to run a loop. So I'm going to run a loop for integer, say I starts with 0, right? And up till until when I have to run this loop. Of course, I can use, by the way, I can use a while loop, which is more easier than this one. Let me just run this while loop. What I can say is while okay, before that, I have to create a temporary node so that I can point to the, so I'm going to do node temp is equal to new of node, right? So why I'm going to create this temporary node so that I can make a pointer. I can point to the first node, then I can move to the second node, then third node, then fourth node, up to end of the list. That's why I'm going to create this temp node so that this temp node will be a pointer for me to move through the whole list. That's the only purpose of this temp node. And then I'm saying while temp.next is not equal to null. We know that only the last node, the next part of the last node is null. So that means until it is not null, go and scan every node, right? Until you, and as soon as you reach to the null, break this loop. And what am I supposed to do in this loop? So suppose the first node contains some data. So what I'm going to do, str is equal to str plus whatever this temp is pointing dot data, right? Get the data. So for example, temp is pointing to the first node, right? Which I have to actually do it here. Instead of calling it constructor, I have to point it to the head, right? So the temp node is pointing to the head so that I can start from the beginning. Temp node is pointing to the head is 250, so we'll be to the first node, and so on. So get the data out of that, and then add a comma and a space, and then a semicolon, right? I will come back to this toString method later on once again, but I'm writing now just to test my add first method is working right or not. And then I have to move this temp dot next to the next, so to the next node in the list. So I'm going to say temp is equal to temp dot next, so that this can move to the next one. After this loop is over, what happens? Until this, this loop will be over, will break when it will reach, the temp will reach to the last node, because last node contains null. So I'm going to extract the data of the last node as well, and I am saying whatever str contains, add this this temp dot data now, because temp is pointing to the last node. Get the data from the last node as well, and the closing bracket, right? So that's it. Add it to the temp to the str and return the str so that we can receive the value over here. Now I'm going to call this toString method in my main program to test whether this data, this 50 is added into the list or not. So I'm going to say sysout the list, right? So if I do this, so it tells me that 50 is be added into the list. Okay, why the opening parenthesis is not there? Let me just see, figure it out. Str is equal to, oh, okay, right. So str, because it is going to overwrite it, str plus, right? So that's all fine. Now, for example, if I try to add one more in the beginning, so if I say list dot add first 40, so 40 will be added before 50, that we can test here. Perfect. Let's say, for example, if I say list dot add first, say suppose 90, so 90 will be added before 40, because in the beginning, that's perfectly fine. So what is happening here? Let me just now explain once again. When I wrote 50, a new node was created. Let me explain it now. A new node was created like this one, right? And now when I say add first 40, then what happened? A new node is created once again, right? Let's say, let me just draw it so that we can see. So a new node was created, right? That contains two parts. And say suppose now this node was created on an address. I mean, this is no more the new node now. This is now gone. So this is my new node, right? So this is the new node that is created. This is the new node that we have created, right? So this new node is created on an address, say suppose 290, right? And then what happened is 40 is stored in the data part, and whatever was in the head node, right? What we are saying here? See what we are saying here. New node dot data is equal to data that we have stored 40. New node dot next is equal to head. Whatever head is having, store that value to the next part of this new node. So head is having 250 that I'm going to store it here. So 250, that means this node is having the next to this node is this node, right? Node is pointing to this node now. So head is also pointing to this point, and the new node is also pointing to this one. But at the next line, I'm saying head is equal to new node. So that means head now will be updated with the address of the new node, which is 290. So that means here in the head node now, the head would now have the value, which is now the 290. So head is having 290. So that means head is now not pointing to this node. Instead, head is pointing to this node, this newly created node, right? So in that way, this node is created first, and this node, existing node, becomes the next node at the last. Now, for example, if now I said add first 90. So if I say so, what will happen now is a new node once again will be created, right? So suppose a new node is created, right? With the let me just create this new node that also has two parts, right? And now this is no more the new node. This is the new node, right? So this is my new node now, which is created. Let's say new node, right? And what we are doing here, what we are saying here is, in this method is saying new node dot data is equal to data. So data was 90, so we stored 90 in the data part. Then what we are saying, new node dot next is equal to head. Whatever is the value of the head, store it at the new node dot next. So the head has 290, so this will contain 290. Now that means this is pointing to this node now, right? So okay, and the next line we are saying head is equal to new node. New node, say suppose, is created on an address 370. So head will be having 370 now. So the head will now be updated with the new address, which is 370. Let me just put it over here, 370. So that means head is now not pointing to this node. Instead, head is pointing to this newly created node, which is this one. So this node, this way, is added in the beginning at the first point, and all the other nodes have moved one step next. Actually, not moved one step next. We just updated the addresses. It's not like an array that we have to move next, right? It is just added at the beginning, like this way, right? So this is how we are going to add the new nodes into the to the linked list. Let's say, for example, if now I say list dot add first, for example, say 15. So 15 will be added in the beginning in the same manner. So let me just reiterate one more time that what happens. So as soon as you say that, it will create a new node. Let's say a new node is created over here. Let me change the color so that we can distinguish these nodes, right? So let's say the new node is created with this color now, right? And that contains two parts, data part and the address part. And you said, let me say, this is the new node now, right? This is my new node. And what I'm going to say is, say this is created on an address 740. And what we are going to do, we are saying in this new node, whatever data you have received, store it in the data part. So the data that we have received is 15. So I have stored 15 over here. And then what it says, whatever head contains, store that into here. Head contains 370. So 370 will be stored here. So that means this is going to point to the node which is at the address 370. And then whatever the address of this node, store it into the head. So head will be now updated once again. So head will be pointed to the new address, which is 740, right? 740, which is this one. So head contains 740. So this is 740, and head is pointing to this node now, right? So this is how we are going to add node at the beginning, at the first place. Let's move next and write few more methods. Let me write the method for add at the last. If now I want to add a node at the end of the list. So for that, I'm going to write a method public void add last, which also receive T type of data, of course, right? We need to have some data. Now, in this point, what I have to do, I have to now move at the end of the list, and then I will place the list over there. But in either case, I have to create, first of all, I have to create a new node, of course, of type T. New node, right, is equal to say a new of node, right? So a new node will be created. So let me just illustrate over here at the same time. So for example, this is no more the new node. This is also not the new node, right? These are the nodes that have been created. Now I'm going to create a new node. Let's say the new node is created at some place here, right? This new node is created that also contains two parts, of course, right? And this node we are intending to add at the last, right? In my main method, I'm going to call the method add last, right? List dot add last, and I want to add, for example, 25, right? So that is what I want to add. So what I'm going to do, what am I supposed to do here is I need to, this node, for example, is created on some address. Let's say the new address of this node is 160, right? So this node is created an address 160. So what am I supposed to do is, first of all, let me move the data to the data part. So what I'm going to do is I'm saying, hey, new node dot data is equal to data that you have received. So after writing this line of code, the data part will contain the data which I have to add here is 25. So 25 will be moved here, will be written over here. Right? 25 will be written over here. And then what I have to do now, I have to find out what is my last node, right? I have to find out the last, because this node I have to add in the last. So in order to reach to the file, remember, linked list does not provide us the random access. It is a linear access. So that means I have to start from the beginning, and I have to move, in order to move to the last, I have to keep pointing to the last node. In order to do so, I'm going to create a temporary node that will help me to point to the last node. So what I'm going to do is I'm going to create a node, say of type T, with the name temp is equal to, and I'm going to put the head node into that one. So head. After writing this line of code, what will happen? A temp node will be created like this one. A temp node is created. Let me just create it over here, right? Let's say this one. It is a temp node, right? Let me just put the name over here. This is my temp node, which I am going to say is equal to head. What a head contains 740. So 740 will be pointed out, will be here. That means this node is pointing to this node as well, right? This temp node is pointing to this node. Remember, the temp node I have created without calling the constructor of the node class. So if I call the constructor of the node class, this will create two variables. One is the data part, another one is the next, which will hold the address of the next part. But since I do not call the constructor, so it does not contain those variables, those instance variables. What it contains is whatever the head node contains. So head contains the address of some node, so it contains the address of that node. Now, so temp points to the first node now. Now I have to actually reach to the end of the node. How can I reach to the end of the node? I can simply run a loop for integer I, which start from 0, right? And I is less than, up till when? To the last. How should I know what is the last node? That size is going to tell me this list of the size, right? So size -1, because indices start from 0, sizes start from 1. So that's why I'm going to run it to the size -1 and I plus plus. What am I supposed to do in this loop is simple. I'm saying temp is equal to temp.next, because I just need to move to the last node. What will happen in this loop? Let me just explain that what will happen in this loop. When I is 0, right? So what temp.next contain? So temp is pointing to 740. 740.next contains 370. What am I saying? Temp is equal to temp.next. Whatever next is, it is going to contain 370, right? 370. That means it is not pointing to this node now, it is pointing to this node. Let me just remove this pointer now. This is not pointing to this node, this is pointing to the next node now after the first iteration, right? After the second iteration, when it is still less than size -1, so it says temp is equal to temp.next. Temp is pointing to 370, which is this one. 370.next is this one, right? Let me just show you guys this one, right? Which is 290. So this will be updated to 290, right? 290, which means this is now pointing to this node. So temp is no more pointing to this node. Temp is pointing to the next node, right? Okay, and the I is incremented. I is incremented to 3, right? I is incremented to it started with 0, then it started to move to 1. Now it is 2. Now, right? So this is pointed to this one. As soon as it reaches to 2, the size of the list is 3. So 2 minus 1 is 3. So 2 minus 1 is 3 means this is now going to stop, right? Loop is going to stop now, right? So the loop has to run for size -1, which is 2. So this loop will stop. So temp contains 290 now. So that what after ending out this loop, what I'm going to do now is I'm saying, hey, now what you need to do is whatever is the temp.next, right? So temp.next is 250. That is pointing to this node, right? So what I'm going to say is temp.next is equal to the new node that we have created, which is 160. So new node will be placed to this temp.next. Yes, and then the new node dot next should be null, right? So this will add this node at the end of the list. Let's just test this method in our main method. So if I add it at the last, and when I'm printing it, it should be added at the last, which is 25 at the last. Now if I say list.add last, for example, 45 should go at the end, and 45 is added at the last. So basically what happened is we actually stopped the loop earlier. So the loop will stop after that, and this will be pointing to this one, right? And then loop will stop, and then this node will be placed here. So at this point, the address of this node, new node 160 will be placed, right? And this will be marked as null. That's how this add last method is going to add this the nodes at the end. And then this means this is going to point to this node, right, which is this one. And then this temp node will automatically be deleted from the memory because of the Java's garbage collection process. This will delete this temp node from the memory, right? So this would be the position of this node, right? Let's say, let me just move it properly. So this would be the position of the node, say 160 would be here after adding this 25 in the list, right? So we did not add 25. Let me just get it from here. We added 25, it should be there. Okay, so the problem is we actually have not added 1 to the size. So the next time the loop is the size remains the same. So actually this is the problem. So we have to every time we are going to add a new node, we have to increment the size, right? That is why this was the problem. So yes, we got it. So for example, if I now add one more node in the last, add last, So for example, 55 will be added at the last. That's perfectly fine now, right? Okay, so we were able to write the method add first. We are able to write the method add last. Now let's write the method which is add. So remember, if you simply call the method public void add and you just pass the data, right? Actually, add method add the new node at the end of the list. So it's actually same as the add last method. So what I can do is I can simply call the add last method in my this method, and I can pass the data to this add last method that will act actually the same. So what I mean is, for example, if I say list dot add say 65, this should be added at the last of the at the end of the list. That is actually the same thing. Now, if I say list dot add first, once again, I'm going to test 10. So 10 should be added in the beginning of the list, which is perfectly working fine. Let me just remove some of the stuff here from now so that we can say, let's say this one. Okay, let me just remove 45 and 55 also so that we can see the shorter list and we can work with that. Okay, now let's move next and write a method to add some data element, a new node at a given insert, given address, a given index number, which means we want to insert the node between two nodes, which was the biggest problem in the array, right? In the array, we have to make this space. Now, let's see what we can do here. So if I'm going to write a method, let's say public void add, or you can call this method as an insert method, right? But that doesn't make sense. I mean, they make any difference if you want to call it insert or you want to call it, let me call it insert. Let's say insert, right? Insert, or actually it is the add. So insert at a given index number, and key type of data that we want to do. Okay, I want to insert. First of all, if the user is going to give me the index number, let's say I am going to say I want to add list dot insert, say for example, at the index number 3, and the data is, for example, 105. So if I want to do so, that means 3 is being received here, right? And 105 is received here. So first of all, I have to make sure the index number that user has given is a valid index number. If the index number is not valid, I can throw an exception. Like I can say if the index is either less than 0 or the index is greater than the size of the list. In both cases, the index is not valid. So I'm going to simply throw new of index out of bounds exception. Right? So this is not a valid index. But if the index is valid, then only we'll be able to reach line number 47. If the index is valid, then what I have to do? Of course, I have to create a new node. So node of type P, new node, right, is equal to new of node. So we are going to create a new node now. Once I have created the new node, what am I supposed to do? Of course, I have to add the data of the new node into the new node. Let's just say I'm going to do some, let me just create this node here so that we can see. Say suppose the new node is created at some point. Let me just change the color of this. Say that I'm going to have this one. The new node is created at this point, which has two parts, two components. One is the data part, another one is the address part. Say suppose this new node is created on an address of 49, right? Some random address 49, and we want to store some data element over here. So first of all, I have created this new node and I have to store that data here. Let's say 105, the data part, I have to store it over here, right? So for that, I am going to say the new node dot data should be equal to whatever the data we have received. 105 that will be received here. Let me just make it correct. This is 105, so it seems like 65. So let me make it 105, right? So 105 is stored over here. Okay, now what next I have to do? Now I have to see at what index number I have to add this node. If the index number is, suppose, if the user has given me the index number 0, that means this should be added in the beginning. If the index number is as equal to the size of the list, that means I have to add this at the last. Or if the index number is in between the 0 and the size, that means I have to be adding this list in the middle, inserting it at the some middle point. So in order to first of all add this, I have to find its correct place. In order to find the correct place, what I have to do, I have to create first of all, let's say what I'm going to do is I have to, of course, I have to find its correct place. But what if the index number is 0? The index number is 0 means this would be the first node that I can check if the index that you have received is equal to 0. In that case, what am I doing? I will now add this into the head. I will do the same thing that I have done in the in my add first method, right? What I have done here is, I will say, hey, new node dot next part should be whatever the head contains, so head, right? That means if it is a new node, it will be having 740 now. That will be that will make the first node, this will be pointing to the first node now. That would be this one. Let's say, let me just do that. Let's say this will contain 740 now, right? 740. That means this is going to point to this node now, right? And then head should point to the new node, which is this one, right? So that means whatever the address of the new node, I'm going to make it here. So that means I want to remove this, and instead of this, I want to store the address of the new node here, which is 49, right? Are you getting my point? So that's what I'm going to do now here is, so once I have it, then what I'm saying is the head now will contain the new node, whatever is the address of the new node. Once you are done, so add 1 to the size, increment the size. And if that's the case, if this was the 0, return end my program. Return means return to the original method, and rest of the code will not be executed. If this is not the index number 0, either you can use return or you can use the else statement after this if, but I am using return, which is the best practice to use in the programming. If the index number is not 0, then index number should be something else, right? So in order to do so, even it is the last index or in the index in between, so I have to find its correct place, right? So let's say for that, I will do the same thing that I was doing here to add at the last. I will be creating a temporary node, will run a loop so that I can find out a correct index number, and then I will store the value. So I'm going to say, hey, node, create a temporary node, temp is equal to, and assign head to this one. So now assume that, let me create a new node. Say suppose a new node is being created. Let's say a new node is being created somewhere here, right? That also is, we are going to store the address of the head, whatever head is pointing to. So say suppose I'm going to create this temp node. This is the temp node, right? Temp node, which is now pointing to 49. So it's going to have 49, which is going to point to this node, right? Which is pointing to this node. So what happens is now, after doing so, I have to run a loop so that I can reach to this index number where a user want to insert the new node. So say suppose in my main method, I want to create at the index number 3, 105, right? One more, right? 105. Let me change it to the 110 so that we can differentiate it all. The only purpose is to differentiate it. So what I want to do is this new node that you have created, let me create the new node. Say I'm going to create a new node now, which is, I want to add this at the index number 3, which has 2 parts. Let's say one is the data part that I already have stored here. So which is the 110 that I have stored. When this method is being called, right? First thing is I have created this new node. I have stored the data into the new node. Then I'm going to check that whether it is 0 or not, right? So in either case, the data is stored. Say suppose this is created on the address 96, right? And then what I am now going to do, I have to find the index number 3 so that I can store it there. So in order to do so, I'm going to run a loop right? I'm going to say, hey, for integer which starts I, which starts with 0, and I should be less than to the index that at what index I have to store. So I'm going to say index minus 1. Why? Because I need to insert at index number 2, index number 3. So I have to stop at index number 2. Okay. So index number 2 and I plus plus. And what I am going to do in this loop is simple. I need to move this temp to the next point. So temp is equal to temp dot next. When this loop will start its functionality, I value is 1, right? Say I value is 1, right? When I value is 0, sorry. So temp is going to say temp dot next. So temp I is 0. Initially temp is having 49, which is the first node. So when I is 0, I is pointing to I temp dot next. So temp is pointing to 740, 49. 740 dot next contain, 49 dot next contains 740, which is this node. So temp will be updated with this address, which is 370, right? This is index 0, this is index 1, this is index 2, index 3, index 4, index 5, right? So now when I will increment, I will become 1. When I will become 1, what will happen? Temp dot next. Temp is pointing to 370, 740. Sorry. So temp is pointing to 740, right? So 740 dot next, which is 370. So temp will have 370 now. So that means temp is pointing to this one. So I will become 2 now. So the index which is received is 3. So I has to be less than to the index minus 1. 3 minus 1, which is 2 minus 1. So here loop will break. So the temp is now pointing to the node which is 370, which is this one, which is the index number 2. That is my purpose. And now here, the new node that I have created, I will insert in between these two nodes, right? Between index number 2 and index number 3. So this new node will be inserted. How? Let's see. Once we are coming out from this for loop, the temp is pointing to the index number 2, right? The index minus 1 where I want to insert. Once I have been there, then what I need to do? I'm going to say, hey, the new node that we have created, dot next, should have the value, whatever temp dot next is pointing to, right? So what does this mean? Let's see. Temp dot next is pointing to, temp is pointing to 740. 740 is this one, right? 740 dot next, which is 290. That is what I'm saying. Place it into the new node dot next. So new dot next is this one. So it will be having 290, right? That means this node is now pointing to this node. This new node is pointing to this node. This is the new node, right? New node. This pointing to this one. Okay, once I am done this, what I am supposed to do next is, after coming out from this, the next line is, now what I have to do is the index number 2 should point to this new node now. That's what I'm going to do. So I'm going to say, hey, the temp dot next, wherever temp is pointing to 370, which is this node, is equal to new node, right? Right? What does this mean? See, temp dot next, temp is pointing to 370. 370 dot next, which is this one, should be now the new value, which is the new node, which is 96. So this is pointing to 96. That means this is now pointing to this one. So this node is no more pointing to this node. This way, this node is inserted, this new node is inserted in between index number 2 and 3. So this will become index number 3 now. This will be index number 4. This will be index number 5 now. This will be index number 6, right? This is how we are going to insert one node in between these two nodes. All right, I hope the concept is clear. Just pause it, rewind the video to grasp this concept, because this is a very, very important concept. Okay, once I am done this, what I'm going to do, I have to increment this size now. Size plus plus. So size is incremented, that's it. So if I now run this code, let me go to the main where I am inserting 110 at the index number 3. So index 0 contains 15, 1 contains 90, 2 contains 40, 3 contains 50. So 110 should be inserted between 40 and 50. Let's run this code and see. So 110 is inserted between 40 and 50. That's pretty much simple. Let me now say, after this, let's say I'm going to say list dot insert. So suppose I want to insert at the index number 5. What I want to insert, say 120. So index number 5 is 0, 1, 2, 3, 4, 5. So that means it should be inserted at the index number 5 between 50 and 25. Let's see. So, okay, something is wrong. Okay, we did not print it. That's the problem. So sys out list, we have to print it once again. So 120 is inserted between 50 and 25 at that particular index number. That is how we are going to update the addresses, and we are going to insert the nodes in between like this one. So if you observe from here, the add first, right? Add first is actually adding at the 0th index. So instead of replicating this code, replicating this whole code, what I can do, I can simply call this insert method by passing 0 as an index and data as the data value. So this will save a lot of my code, right? So 0 will be received as index number and data will be received, which is going to insert this at the 0th index in the beginning of the list that add first was doing. Same thing I can do with the add last. Add last is going to add the list at the last element. So instead of writing this whole code, replicating this code, what I can do, I can call this insert method and I can say, hey, add it at the last. Last means add it at the size, right? And which would be the index size minus 1 index, right? And whatever is the data, pass it to this one. So this will actually do the same job. So if I run this code, no changes there. The only thing is my code is more efficient now. My code has less line of code. Just pause the video, see what I have done in this one, right? Okay, now after this, let's now write the code to remove a node from the list. So, okay, so let's write this remove method. I'm going to write the remove on a given index number, and then like we have seen here, if we are able to write a method add or insert at a given index number, then we can call that method for add first, add last, and add. Similarly, I'm going to write the method remove at a given index, and then we will call this remove method at a given index in the remove first, remove last, and all other methods. So I'm going to say, hey, public void remove integer index, take the index from where you want to remove. Right? So that's the only argument that I'm going to receive here in this remove method. First of all, what I need to do, I need to make sure this index is a valid index. So how can I do so? If index is less than 0 or index is greater than the size, right? Greater than or even equal to the size, right? Because size is one more than the index number. So here we are expecting the index number. So it should be greater than or equal to size. In that case, throw new of index out of bounds exception, right? Throw this exception. If the index is valid, then we will be able to reach to the line number 55 of this code, otherwise not. So if I am able to reach here, what am I supposed to do here? First of all, I have to check if the first node is being removed, then it is very simple, right? If only the first node is being removed, then what I have to do? I just need to move head pointer to the next node. That's it. And my node will be removed. So what I am going to do, if the index is equal to 0, index is 0, in that case, the index is 0. Then what I need to do? Simple, move head is equal to head dot next. What will happen when I write this code? When I write this line, it says whatever head dot next contain, head is pointing to 49, right? Head dot next is 740. So update 740 here in the head. So this head will now point to this node instead of this. So this node is removed from the node from the memory. That's it. Garbage collection will automatically remove it. That's what I'm going to do, right? That is simple. And then what I need to do is I just need to decrement the size, right? Decrement the size. So size is decreased. And I need to return my program that I am done. If the index is 0, just move the head pointer to the next node, decrease the size, and that's it. But what if this is not the case? The removal is at some other node, maybe in the in between, in some other index number, or at the last index number. In order to do so, what I have to do now, I have to actually find out 2 pointers. So let me just clean this so that we can see. Let's say I'm going to erase this part now, because this node we have already removed, right? So we are assuming that we have removed this node. So what we are going to do now is I need 2 temporary nodes. One node, let's say, assume that I want to remove this, whatever is at the index number 4. So right now indices are starting from 1 because I have removed the index 0, right? So here, if I want to remove this node, what I need to do, I need to make 2 pointers. One pointer which is pointing to the node previous to this node that I am going to delete, and one pointer which is after the node, after this node, so that I can fix those pointers. Let me write the code, and then I'm going to explain it. So what I'm going to do is I'm going to say, hey, create the temp node is equal to, and put a head over here, right? So that I can move to that particular index number from where I am going to delete it. And then I'm going to run a loop for integer I mean, similar to the like we were running a loop in the insert method. I starts with 0, I is less than the index that you have given to me minus 1, because the index I have to delete, I have to move one step back, index minus 1, and I plus. And what I am going to do, simply move the pointer. Temp is equal to temp.next, right? So that I can now, after the end of this loop, one of my pointer, let me just show you. What happens is one of the new temp node will be created. Say this is the temp node. Temp node will be created, right? That will have start from head node from here, then move to this node, then to this node, and index minus 1. Since I want to delete the index number 4 up to this index number 3, will hold this address, which is this 96, right? So this will be pointing to this node 96, right? Okay. Once I'm done here, then what I want to do is I want to now actually have another pointer that I want to move after this. So node t, say temp2 is equal to what I'm going to store here is temp.next, right? So whatever temp is pointing to. So temp, what does temp contain? Temp contain 96. Temp is pointing to this one. Temp.next contain 290, which is this node that I want to delete, right? So a new node temp2 will be created. Temp2 will be created, which hold the address which temp.next is, which is 290. So temp2 is holding the address 290, right? Okay. After that, what I'm going to do, that means this is now going to actually point to this node, which is at the index number 4. Okay. Then what I'm going to do next, after doing this, what I'm going to do is I'm saying, hey, after this, temp.next is equal to temp2.next. So after writing this line of code, what does this mean? This means temp.next. Temp.next is this one, this part, right? Temp.next is this one. Temp is pointing to 96, which temp.next is this one, this portion, is equal to, updated with what? Temp2.next. Temp2.next means temp2 is pointing 290, which is temp2.next is this one, 250. So put 250 here at this point. So this is now pointing to 250. That means this node is now pointing to this node, 250. That is my goal, right? So after this, when I have done so, that means this node is no more part of the list anymore, because this will be actually bypassing this one, right? And then after doing so, what will happen? Java's garbage collection will delete temp2, temp, and this extra node, right? So what will happen is, let me just erase this whole so that we can understand. This will be removed, right? This will be removed from the memory. This is removed from the memory, right? This is also removed from the memory. So that node is deleted from the memory. garbage collection will automatically do so. And also, after I have done so, what I need to do, I simply need to decrease the size, decrement the size. That's it, right? That's how we are going to remove a node from a linked list, right? Okay, now let me write this method now, public void remove first. Remove first means I want to remove whatever is at the index number 0. So what I can do, I can call my remove method that I just written on the index number 0. That's it. It will do my job. That will actually run this condition and will do my job. And if I want to remove the last node, public void remove last. That means I want to remove the last node. Last node means whatever is the size minus 1. Size is, I mean, the list size of the list, and I need to pass the index. That is, the index is 1 less than the size. So I'm going to say size minus 1, right? That's it. That will do. Okay. So no. So that is actually I have to call here. So call the remove method on size minus 1. That's it. This will do my job. That's it. We are done, right? So we are able to remove at a given index, remove first and remove last. And remember, whenever you write simple remove method, right? Public void remove. Remove, always remove a node from the last. Like add, always add a node at the end of the list. Similarly, remove removes the node from the end of the list. So I can simply call a remove last method here to remove from the last, which is going to remove from the size minus 1, right? Let's test this method. So what I'm going to do now is I'm going to say, hey, you have already done insertion and everything. This is the status of the node list after adding and inserting all that. But now I want to remove. So suppose I want to remove at the beginning, for example. So remove first, remove from the beginning first, right? List dot remove first, sorry. So list dot remove first. So, and then print out the list once again so that I can see either the first is, so first node is 15. So after this 15 should remove, 19 should be the next node. So my remaining list is this one. All right. Now, for example, if I say now list dot remove last, so that means 50 should remove. And then if I print out the list once again, if I print out the list once again, it should print and 50 should not be part of the list now. Okay, what happened here? Okay, sys out, we printed sys out list, right? 50 is no more part of the list now. All right. Now, for example, if I want to remove after this, so for example, I want to remove 110. So 110 is at the index number 2, 0, 1, 2. I want to remove at the index number 2. So what I'm going to say, hey, list dot remove from the index number 2, right? At the index number 2. And then I want to print out the list once again. You will be able to see 110 is no more in the list. So 110 is removed from the list. Now, if I want to simply call the remove method, so list dot remove, only remove actually is calling remove last in his own method. So that means 65 will be removed from the list. Now let me print out, say sys out, print out this list once again. So 65 is gone from the list. So we are able to write add, insert, and remove method in our own linked list class. Now let's move next and write few more methods. Let's say, for example, now I want to write the size method, the simplest one. So size method is very simple. Public, this returns integer size, right? It simply returns whatever is the size. That's it. Okay, fantastic. Now let's write the get method. Get method, again, I'm going to write get at a particular index number, and then we will call get first and get last method by passing the indices to that. So get method is actually going to tell me what is the data stored at a given index number. So public, it return T type of data, right? Public, T type of data get, right? At a given index, integer index number. At what index number you want to get the value? So again, first thing that I need to do here is to make sure that index is valid. So for that, you already know now. So if the index is less than 0 or the index is greater than size, simply throw new of index out of bounds exception, right? So, but if this index is valid, then what I have to do? Then I have to reach to that particular index and then return the data. In order to reach to that index number, I need to create a temporary node that you have already seen. You have the idea now that we need a temporary node. So I'm going to create a node temp is equal to, and I'm going to start from here because from head I will run a loop and I will reach to that index number so that I can retrieve its data. So, and now I'm going to run a loop for integer I, which starts with 0, and I is less than this index, right? And I plus plus. What am I supposed to do in this loop is simple. Temp is equal to temp.next, because I just need to move the pointer, temporary node pointer, to the node to the index number where I have to reach. Once this loop is over, I will be at the index number that is my desire, that the user has given. In that case, what I can do, return temp.data. That's it. I just need to return that data. That's all, right? Isn't it? Let's say let me test this method. So for example, if I say simply sys out, print it out directly, you can store it anywhere. I mean, if you want to store, or you can simply print it out here. For example, I say list.get get from the index number 2. So it should print 25. Let's see. Perfect. If I say, for example, at the index number 4, so it should tell me that this is the okay, so it is going to throw the exception, right? So, but this exception is not the exception that I want to throw. That means it should be greater than or equal to the size of this one, because the size is if user may throw this one, right? This is the exception that I want to throw, index out of bounds. So why I have make it index is greater than or equal to 0? Because a user can, I mean, we have to the index, we need to find out that index, we have to move there. So that's why whatever the index user has given, if that is even equal to the 0, we will get the value from that. For example, if the index number is 3, it should tell me the index number 3 is 120. The index number is 0, it should tell me the value is 90. If the index number is -2, it should throw the exception, which is index out of bounds. The index number is 1, it should tell me the value, which is 40. Perfectly fine. Now let's get back and write the get first and get last method, which is now very simple. Public key type of data get first, right? So what I can do, I can simply call this get method on the index number 0. That's it. So I can simply say I can say, okay, return return whatever is available at the get of 0, right? Let me see whether it works or not. Let's see. Get, I have a doubt. First. So it works perfectly fine, right? Okay. So get first method, we are able to write, right? Return whatever is at the get of 0. Now let me write public t type of get last, right? Get last. So get last, return whatever is at get of size -1, right? So let's say, let me test this one. If I say get last now, sys out, print out list dot get last, right? Should be printing 120. Perfectly fine, right? So last is going to tell me what is the last value. First is telling me the first value, and get is going to tell me whatever is the value at any given index number. So we are able to write the get method. Now let's write the set method. Set method is used to change the value at a given index number. So public void set the value at the given index number. So give me the index number as well as give me the new data that you want to set, right? That I want to set over here, right? Okay. Now, again, first of all, what do I need to do? I need to check. I need to make sure the index is a valid index. So integer index, either it is less than 0 or if it is greater than size, say index is greater than or equal to size, in that case throw new of index out of bounds, oops, exception, right? Otherwise, if it is not the case, then go to that index number and change the value, modify the data value. How to go to that index number? We have just seen even in the get say case. So I will create a new node which is for the temporary purposes with the name temp is equal to, and I have to set head here, and I will run the loop to go to that index number, right? So for integer, say I starts with 0, I is less than the index I plus plus, right? What I am going to do, temp is equal to temp dot next. You already know that how it works now. After the end of this loop, I will be at the index number. My temp will be pointing to the index number that I need to modify. In order to do so, what I need to do, I simply can say temp dot data is equal to the new data that I have received as the argument. That's it. Let's test this method. Say, for example, I can say now, let me just remove these two line of code, right? And this is the position of the list. I want to change 25 to 50, which is index number 2. So I can say list dot set at the index number 2, set it to 50. And then after that, print out the value of the list, sys out list. So 25 should be replaced with 50. Perfectly fine, right? It is working. Great. So now we are able to write this get method, set method, all those methods. Now let's write the clear method, which is again one simplest one. Clear method is simply going to clear the list, right? So that means it is going to remove everything from the list. So in that case, what I need to do, let's see. Let's say public void clear. It will remove everything from the list. One easiest approach in the clear method is to set the head to null. What do I mean is I'm going to say a head is equal to null. So when you call this clear method, set will be set to null, meaning all the rest of the nodes will be non-reachable, and Java's garbage collection will delete them automatically. Let's see. If I now after this call this method list.clear, right? This should make it null, and now if I print it out, it should print nothing, right? Okay, so it is going to throw the exception, null pointer exception. Let's see where the exception is. Okay, so the problem is here in the toString method, because in the toString method, we are also using the head node, and we are saying while temp.head.next is not equal to null actually, and the head node we are making null in the clear method. So null.next is obviously going to throw the null pointer exception. So in the clear method, let's twist this toString method. So in the clear method, first thing is we need to actually make head as the null. And the second is we also need to actually say size is equal to 0, right? We are going to call the size is equal to 0. Or in other words, basically you can say, you can actually create the new object as well. But anyways, and in the toString method, I'm going to do some twist. What I'm saying is if the head is already null, you do not need to run through the loop. In that case, simply return whatever str container, which is the opening bracket plus the closing bracket. That's it. This should work well now. Let's see. Yeah, that's perfectly fine. So as soon as you call a clear method, so the clear method is going to clear them all, and it's going to be the list is being printed nicely without any, I mean, it doesn't contain anything. Now let's get into and write our last method for this linked list class, which is the contains method. Contains method, as we have seen in the array list, is actually receives one data element and will find out if the data is present in the list or not. So I'm going to say here public, and obviously it is going to tell me either true or false. So Boolean contains, right? It receives T type of data that we want to find out from the list. And how can I find out the data from the list? Of course, I have to scan the complete list. There is no way that I can perform a binary search or anything else. So I have to scan the complete list. In order to scan the complete list, again, I need a temporary node. So I'm going to create a node first, which is temp, and I'm going to start it from the head node so that I can move along the head to the tail, to the end of the list until or unless I find out the data that I am looking for. Okay, what I'm going to do now is I'm of course going to run a loop, integer I, which starts with 0, right? And I is less than the size of the list and I plus plus, because I have to scan the complete list. I am going to scan the whole list. And then what I'm going to do here is I'm going to check. Obviously, I'm going to say, hey, if the temp.data, if the data dot equals to what? The data that you are looking for, right? That we are looking for. If the data of the temp is equal to the data that I'm looking for, in that case, simply return true. If you are able to find even the first occurrence, return true. But if after coming out from the loop, if you are unable to return, I mean, if you will be able to find the data, you will not be able to reach to the line 117. This will return true at line 116. If it will find out the data from the list. If not, that means the loop is over and the data is not available. Here I can return false from here. That's it. That's the only thing that I have to do. Now let's get back to the main method and find out the data from the list. Let me just remove this, that I do not want to make it clear at this point. And then I am going to find out, this is the position of the list. Let me find out 40 out of the list. Does this contain 40 or not? So I can directly print out, say, for example, list.contains, say 40. So it should tell me true. Oh, it's telling me false. Let's see if it, what happens to this one. So let's see if temp.data equals to the data that we are receiving here. Oh, okay. The reason is we are not going to move to the, okay. After this, actually, we have to move to the, I mean, in the for loop, we have to move to the next of that one, right? So for example, temp dot next. Temp is equal to temp dot next. We are not moving temp to the next position. That was the problem. Our loop is in the ith, on the ith iteration, but we were not moving temp to the next one. This should now work fine, right? So it returns me true now. So for example, if I'm looking for, let's say 120, this should tell me that 120 is true. If I'm looking for 90, 90 should also be part of the list, is all fine. But if I am looking for 190, this should tell me that it is false, right? So contains method is also there, which is going to simply, we are going to use it like this one. So these all are the methods that we have implemented in this linked list. Now let me just remove these annotations so that we may let me make it clear. Let me just select that all and remove that so that we can use this space now. Okay. Now let's say I'm going to remove this all. Can I have created this list as a generic list. Can I create this list for a specific data type? Yes, you can use the angular bracket here. You can specify, for example, you want to create for the strings. You can let me add the values here. So for example, list.add, let me add first. For example, I'm going to add first element as hello, and then I'm going to add list dot. Say suppose I want to add the last. Add last, for example, hi. Let's say for example I want to add list dot add in between at a given index number. So for example, I want to add at index number 1. Okay, this is the insert method. So dot insert at index number 1, and I want to add welcome. So that's how we are going to add, and then I can print out this list, sysout list, right? So it's simply going to print it out. You can try all these methods and you can test once again. Now, let's get back here and see what is the time complexity of each and every method. So that is very, very important now. Let's say, for example, let me grab this list of methods here, and let's find out the time complexity of each and every method. So when I'm going to add something, right? So add first. So let me try from the add at a given index number. So adding add that was basically our insert method, right? This is, we have renamed it to the insert method, right? So what we are doing in insertion and deletion, if you observe here, where is my insert method? Insert method. So in an insert method, what we are going to do, we are going to simply update the addresses, nothing else. So it actually runs in a constant amount of time. So it only takes O of one time, right? O of one time, right? So similarly, this add last, add once, all of these methods are calling this insert method. They all take O of one time, which is super easy. Similarly, all these remove methods, they take O of one time, which is the constant time to remove from a linked list, because we just need to update the addresses. That's it, right? And then finding out the value, getting the value from the list. This is something, including the set. Here you have to actually reach to that index number. This needs O of n time. In a worst case, if you are going to find the last one, it is O of n, right? Size and all that is contain is also going to give you the O of n time. So if you want to access some value, change some value, or search some value, this is the worst data structure that we can have, which is O of n, which takes O of n time. That is the only drawback of the linked list. In addition to that, it also consumes some extra space I mean, as compared to the array. But then if you are going to have some problems where you need to add or remove the values very frequently, then this in the linked list is the best data structure as compared to the arrays and the array list, right? Array list is still a class. So that's all about the linked list. In the next week, we will talk about the queues and the stack and rest of the data structures. Until then, take care and bye.